Today we will study the creation of a singly and a doubly linked list. So just we'll start what is a linked list. Okay, so linked list is a data structure. Okay, it is a type of data structure. You know the data structure we use to store elements. Okay, so how are we storing elements using linked list? So consider there are elements like A, C, E. Okay, I have three elements in my hand, A, C, E. I want to store this data in a linked list. So how I am going to do it? Okay, so linked list always we store the data in form of nodes. Okay, so this is a node. Okay, this is one node. Okay, this is a node. This is a node. Okay, so a node has two parts. One is data part. Here this place is where we store the data, and it has a link part. So what is data part? Data part stores the data what we have. For example, in our hand there is A, C and E. Either A or C or E is being stored. And what is this link? Link means we store the address of the next node. Okay, so this link is used to store the address of the next node. So we'll just see that in a detail. See, linked list means it's a data structure, but it is also collection of nodes. So if I'm saying collection of nodes means there will be lot of nodes. Okay, this is one node, this is the second node, this is the third node. Okay, now as I have only three elements in my hand, so I have taken three nodes. Okay, and what I'm going to do is in the data part I'm going to store the elements. Okay, first one A for the first node, C for the second node, and E for the third node. Now I have to see the address. Okay, so once a node is being created, an address will be given to this node. So consider this address of this node. The first node is 1000, second node is 2000, 3000. So this address will be given as soon as you create the node. Okay, so now I told you this A will have the address of the next node. So address of the next node is 2000. So this 2000 will be here. Okay, similarly C, this second node which has the data C will have the address of the next node. The next node address is 3000. Okay, and now E is the third node. Third node has the data E, and its address will be the address of the next node. So you can see there is no nodes after the third node, so you can put here as now. Okay, so you can see there is a connection between A and C. They are connected through the address 2000. That means as the first node has the address 2000, it is connected to the node having the address 2000. Similarly, the second node is connected to the third node using the address 3000. Okay, so this is a linked list, and the most important part of a linked list is there will be a header. Okay, usually we call this as first, or you can call it as header. It is your wish what to call. Here I am calling it as first. So every linked list will have a header. So first is the header here. And what is this first? First is a pointer variable. Okay, first is a pointer variable. You know what is a pointer variable? A pointer variable will have the address of another variable. It will have the address of another variable. So here if you see in a linked list, see the first, anyway it has to store the address of another variable. Here there is no variable to store, but there is node's address. We get the node's address. So I can say here first will be the pointer variable that stores the address of the first node. Okay, here there is no variable, but we have node. So first will be storing the address of the first node. So uh, automatically the value of first will be 1000, because 1000 is the address. These are all the address of the nodes. So the first node has address 1000. So this first header will have the value, first will be having the value 1000. Okay, so this is how the linked list looks. So let's move. Okay, so I just want to recollect once again. So we have linked list. Linked list is always a collection of nodes. Okay, it will be a collection of nodes. Okay, here I have three elements which are A, C and E, because the first part of a node always stores data. The second part stores address. We call it as link. Okay, link means the address of the next node. Okay, so whenever you are creating a node will always gives its address. So imagine these. A first node has the address 1000, second node 2000 and the third node 3000. And how it is connected? One node is connected to the next node using the address of the next node. So here it will be 2000 and here it will be 3000. There is no node for the third node. Third node is the last one, so we will write here as null, and we have a pointer called first which stores the address of the first node. So that will be 1000. Okay. So now this type of linked list, is called as singly linked list. Singly linked list. So we have another one as called as doubly linked list. So before that, I'll teach you what is circular linked list also. Circular linked list, there is no difference. If suppose these are your datas A, C and E, instead of characters you can store integers also, no problem. So you have 2000 over here, it gets connected. Let me write the address 1000, 2000 and 3000. Okay, so A to C is connected, C to E is connected using the address 3000, and E will be connected to the first node. Okay, E will be connected to the first node. So this will have the address 1000, and we have a header called first which will contain the address of the first node, that is 1000. So this is called as circular singly linked list. That is, whenever you find the last node connected to the first node, it is called as circular. Circular here in this circular singly linked list. Now we look for doubly linked list. What is doubly linked list? Doubly linked list is, again we have data A. Consider there are three nodes C and E. Here doubly linked list will always have a data part, but it has two pointed parts, that is R link as well as left link. So you will not have this there is some change in this node. What will happen here? The node will have three parts now. This is for left link, this is for right link. Similarly, this will be for left link, this will be for right link, and in between it will be data only. So this is also for left link and this is for right link. Okay, consider when we created this first node, we got it at address 1000. When we created a second node was created at 2000 memory address, then this 3000. So how are we going to link this? Let's see. Okay, now here what we are going to do is see. Okay, A is there. Okay, its left link, there is no one to connect. There is no one. Okay, no nodes are there. See, right link and left link are both pointer variables. Okay, these also hold the address of the left link will hold the address of previous node, and right link will hold the address of the next node. Okay, so keeping that in mind, we'll just say left link means there's no previous node, so this will be null, or instead of null you can write like this also, no problem. Okay, right link, there is next node which is at 2000, this is at 1000. Okay, and now, so as it is telling 2000, there will be a connection like this. Now to this node there will be a connection like this. Now this node also has a left link data and right link data is C. Now left link, it has the address of previous node. So this is at 2000, the address of previous node is 1000. So what happens? There is a link like this to the previous node. Now R link of the second node will be 3000. So automatically there will be a connection with the next node which has the data E and stored in 3000. Now E will have, left link has the address of the previous node, that is 2000. So automatically there will be a connection like this. And here for right link there is no next node, so this will be null or /0, anything you can put. So this is called as doubly linked list. Okay, and what is, there is circular doubly linked list. Circular doubly linked list is also it will connect backwards. Okay, so how is that? There is no change here. A, let me write the datas, C and E. So here this left link of A will have connection to the last node. Okay, this will have connection to the last node. Okay, so this is 2000, 3000. So automatically here the value will be 3000 as there will be a connection. Now A's right link will be 2000, so there will be a connection like this. C's left link will be 1000, so there will be a connection like this. And C's right link, there will be 3000, there is a connection like this. E's left link will be 2000, so there will be a connection like this. And this will have the address of the first node, which is 1000. So you can imagine it, I'm sorry, it will go like this and gets connected. I'm sorry, here all first will be there. Okay, first will be there, which will have 1000. Here also we have the first header which will have value 1000. So this is circular doubly linked list. So our topic today is the creation. How will we create these nodes? Okay, how will we create doubly linked list and circular doubly linked list? So we'll just see that. Okay, so in order to create node which has the data part and also a link part, we know the data can either be character or can be integer. Link part is a pointer variable, so which is neither character neither int. Okay, so we know that if we have different data types, or if we have different data types, at the time we can use structure to create it. Okay, so structure, the keyword is struct, and I want to create a node, so I'm giving name node, and that node will contain a data part. Here I'm going to have character, you can also have int, whatever is it. Okay, and then link is a pointer variable. So you write like this, link is a pointer variable. Now you know this link contains the address of the next node. That node also, see, this link will contain the address of the next node, which also has a data part, which also has the link part. So actually this is a node. Okay, node which has a data part and link part. So I can automatically say this is of type, this link has the address of another node which is of type struct node, because this struct node itself has a data part, has a link part. Okay, so this is how um, in a singly linked list and also circular singly linked list we can create a node. So write struct node. Here you can use also int, no problem, and struct node star link. Okay, after that you can close the bracket. Now you all the nodes, all the linked list will have a header called first. So that first also is a pointer variable of type struct node. So for good practice, it is better to make it null when you are going to create a linked list as new. In a new singly linked list or new circular singly linked list, better create a pointer variable. Better put that pointer variable first as null. See, you can, as we are going further, we need to create many pointer variables. So we will have another pointer variable called last also. If we need a pointer variable called last, the how to write it is struct node star last. That also you put it as null. Okay, so this is how to create a singly linked list and circular singly linked list. Now we can see how to create a doubly linked list and circular doubly linked list. It's very easy. We know that in doubly linked list, the only thing is data is here, but we have a link and a link. Okay, so the difference, only slight difference, we have struct node. This data can be character or integer, and also here instead of link we have a link pointer variable which is of struct node type, and also we have r link which is also struct node type. Okay, then you close it, and then in order to define first, in order to declare first, how we'll do it is struct node star first is equal to none. And also you can use, if you need another pointer variable, imagine temp, you can put struct node star temp is equal to null. Okay, so this is how we declare the structure for a node. We declare a node with data part and link part. Okay, so this is how we declare it. So hope you understood. Thank you.